Run your hand along your jaw right now. Maybe there's stubble. Maybe you shaved an hour ago and your fingers are just checking. You do this without thinking, dozens of times a day, and you've probably never once wondered why that hair is even there. Because you are technically a naked animal. Every other primate on Earth is covered in fur from head to toe. You are not. Your skin is exposed almost everywhere, bare and sweating in a way that barely exists anywhere else in the mammal world. And yet, in the middle of that full body retreat from hair, your face held the line, kept growing, got thicker, coarser, more visible than almost anywhere else on you. That's not a small detail. That's two opposite evolutionary stories happening on the same 6 inches of skin. And the easy answer, we didn't need fur anymore, but we kept beards because people like the look, isn't really true. Not either half of it. Go back roughly 1.5 million years to East Africa. Forests are thinning into open grassland, and an early human ancestor is walking. Not sprinting, walking, for hours, tracking prey across open country with nothing but legs and patience. The midday sun there doesn't feel gentle. It presses down. And this ancestor, like every primate before it, is wearing a full coat of fur. Fur is a brilliant insulator, which is exactly the problem. An insulator traps heat in, and that's the last thing you want when your muscles are already generating heat and the sun is adding more from outside. A coat that keeps a fox alive through winter becomes a death sentence on a savanna at noon, especially for something covering miles on foot, day after day. So evolution did what it always does. Slow, brutal trial and error across hundreds of thousands of generations. Individuals who sweated more efficiently and carried a little less fur ran cooler. They pushed harder, longer, without overheating. That small edge compounded, generation after generation, into something enormous. This is the leading explanation for human hairlessness, developed most thoroughly by biological anthropologist Nina Jablonski. Bare skin lets sweat evaporate straight off the body instead of getting trapped in a coat of hair. And humans became extraordinary sweaters, packed with more sweat glands relative to body size than any other primate alive. Bare skin was simply the price of that cooling system working at all. There's a second idea too. Biologist Mark Pagel has argued that losing fur may have stripped away hiding places for ticks, lice, and the diseases riding along with them. These two explanations aren't rivals. They could easily both be true at once. Here's the frustrating part. Skin doesn't fossilize. There's no ancient body anywhere that lets scientists say, this one still had fur, this one didn't. So how do you date something invisible to the fossil record? The answer came from a gene that has nothing to do with hair. In 2004, Alan Rogers and his team at the University of Utah studied a pigmentation gene called MC1R. A version favoring dark, protective skin swept through the ancestral population and became nearly universal around 1.2 million years ago. Dark skin only becomes a major advantage once you're standing under direct sun with no fur to shield you. So if that gene locked in 1.2 million years back, bare skin was likely already well underway. Not a fossil, a genetic echo, a shadow of something nobody was there to record. And here's where it gets strange. Your hair follicles never actually left. Developmental biologist Sarah Miller at the University of Pennsylvania has found that human skin carries a follicle density comparable to a chimpanzee's. The follicles are still there, spread across nearly your whole body. What changed wasn't the number. It was what came out of them. Thick, pigmented terminal hair got swapped for fine, nearly invisible vellus fuzz. The same soft down still on your forearm right now, except in a handful of places. The scalp, eyebrows and eyelashes, the armpits and groin, and, in men, the face. Why those spots specifically kept producing terminal hair while the rest of the body got quietly downgraded is something researchers are still working out. Scalp hair plausibly shields the skull from sun. The rest is murkier, and the beard is the murkiest of all, because a beard isn't leftover hair the way scalp hair is. Through childhood, a boy's facial follicles produce the same fine fuzz as everywhere else. It's only at puberty, under a surge of testosterone and its stronger cousin, dihydrotestosterone, that those follicles flip a switch and start producing coarse, dark hair. The face isn't a place fur refused to leave. It's a place where hair turns on later, deliberately. What nobody actually knows is when that switch first appeared. Long before body hair thinned out, long after, at the same time, there's simply no genetic clock for a beard the way there is for skin pigment. What research has tested is what a beard signals now. And that complicates the story people usually tell. Darwin's assumption was that women found beards attractive, plain mate choice, the same logic behind a peacock's tail. Tidy story. Not especially well supported. A 2012 study by Barnaby Dixon and Paul Vasey found that bearded faces are rated as older, more dominant, and more aggressive than the exact same face clean-shaven. That result has held up across repeat studies. A follow-up in 2016 by Dixon's team, focused specifically on attractiveness, found something messier. Some women rated beards as more attractive for long-term partners. Others showed no preference, or a mild pull toward clean-shaven. Heavy stubble sometimes beat a full beard for short-term appeal. The female attraction evidence, honestly, is a mess. What's consistent in nearly every study is how other men react. Bearded men are read as more dominant, more formidable. Nobody has proven a beard makes a rival actually back down, but that perceived power points toward a very different kind of selection, aimed sideways at competitors, not forward at partners. There's a small, more recent hint of this too. A demographic study of British facial hair fashions between 1842 and 1971 found beards and mustaches surged in eras with more unmarried men chasing a smaller pool of women, exactly when male rivalry over partners was heating up. Just a correlation from Victorian and 20th century Britain, not proof about deep prehistory, but it lines up strangely well with what the perception studies keep finding. Even beard growth itself isn't a clean, readable signal. It depends on androgens, but how densely a follicle responds to those hormones varies wildly between men. Two men can carry very different testosterone levels and grow nearly identical beards. Or the reverse. There's one more piece to this, dated by an even stranger method. Lice. Human head lice and body lice are the same species, but body lice can only survive in clothing fibers, not on bare skin. Since that adaptation could only happen after humans wore clothes habitually, scientists use the genetic split between the two louse populations as a rough clock. A 2003 study put habitual clothing at around 72,000 years ago. A 2011 study using newer methods pushed it back to at least 83,000, possibly as early as 170,000. Either way, that's hundreds of thousands of years after the 1.2 million year mark for bare skin. Your ancestors spent an enormous stretch of time naked and without clothing, long before fabric, and long before a beard carried any social meaning at all. None of this makes the attraction story flatly wrong. Beards may do both jobs at once, unevenly, depending on culture and the man wearing one. But if you came in expecting a clean, symmetrical explanation, we shed fur because it was inconvenient, and kept beards because people like them. The actual research hands you something messier. Hairlessness and beard growth aren't two halves of one tidy adaptation. Nobody even knows how their timing lines up. What is known is that a beard's clearest, best replicated effect isn't on the people it was supposedly built to attract. It's on other men. Your hand goes back to your jaw, stubble, or smooth skin, whichever it is this morning. 2 seconds, no thought behind it. But underneath your fingers is a follicle doing something it does nowhere else on your body, waiting for puberty, waiting for a hormone, then switching on. A patch of hair evolution chose not to leave as fuzz. And the honest answer, the one the evidence actually supports, is that nobody, including the people who study this for a living, is entirely sure who it was ever meant for.